Okay, now we're going to do the mock AB2 question. So here we have a table of values, and so let's read the problem, and we'll go through the work for each section. Okay, so we have a large pizza chain that delivers pizzas nightly from 6 p.m. to 2 a.m. On a Friday night, the rate the pizza chain receives calls for delivery is modeled by the differentiable function c prime of t. So they're giving you a data on the derivative. Measured in hundreds of calls per hour, where t is in hours since 6 p.m. or t equals 0 is at 6 p.m. Selected values of c of t are given in the table. Okay, first question. Use the data in the table to approximate c double prime of 7. Use correct units and interpret the meaning of c double prime of 7 in the context of the problem. Okay, so since they gave you the derivative and they're asking you for a rate of change of the second derivative at time of 7, time of 7 falls in between 6 and 8, and what you're looking for is a rate of change, which is slope. So this is going to be c of 8, or c prime of 8, minus c prime of 6, divided by 8 minus 6. So it's just slope. So this is going to be 0.2 minus 1 divided by 2, which is negative 0.8 divided by 2, which is negative 0.4. Okay, and if you left your answer as negative 0.8 over 2, that's okay, but this is really easy arithmetic, and again, you can use calculator on this one. Or I didn't say that at the beginning, but you can use calculator on this one. Oh, and now we need to interpret the meaning in context of the problem. So this means the rate of pizza chain receives calls is decreasing because you've got a negative slope at the rate of 0.400 calls per hour at time is 7. Or you could put 1 a.m. Okay, points, you get 1 point for finding the approximation, and then 1 point for the interpretation. Okay, part B. Does the data in the table support the conclusion that there is a time between 0 and 8 at which the pizza chain receives 300 delivery calls per hour? Give a reason for your answer. So, answer is yes. And if you look at the table, you can see that between time is 0 and time is 8, time is 0, there's 500 calls, and time is 8, there's 20 calls. So the answer is yes, and so let's state the reason. Firstly, the function c prime of t is differentiable. Therefore continuous. But remember, the contrapositive isn't true. If a function is continuous, it doesn't mean it's differentiable anywhere. But this one said it was differentiable, so that means it has to be continuous on the interval 0 and 8. And 300 is in between, or between the prime of 0, which is 500, and c prime of 8, which is 20. So that means the intermediate value theorem, and you can abbreviate AB2, guarantees there is a time C, time equals C, between 0 and 8, where C prime of C, that's the value of C here, time of C, sometime between 0 and 8 is 300. So you need to make reference to the intermediate value theorem, but also know what the intermediate value theorem is. Okay, now let's do part C. Using correct units to explain the meaning of the definite interval 0 to 8, C prime of t dt in the context of the problem. Then use your right Riemann sum with 4 subintervals indicated by the data in the table to approximate the value of the interval of 0 to 8 C prime of t dt. Okay, so first, what it means. So the interval from 0 to 8 of C prime of t dt is hundreds of delivery calls received from time is 0 to time of 8. Okay, which just kind of restates, what the description when you first looked at that paragraph. Okay, now a Riemann sum, and we'll write Riemann sum. So remember, we need to get the intervals. Here, we need that. Okay. So our intervals are 0 to 1, 1 to 4, 4 to 6, 6 to 8. There's our 4 subintervals based on the table. Delta x here is 1, delta x here is 3, delta x is 2, delta x is 2. Now you don't have to write all this down, but I want to make sure you see where all these numbers are coming from. So, and we want right. So this is the right side. So those are the function values that we're going to use. So the integral from 0 to 8 using a right Riemann approximation of C prime of t dt, always use good notation, is delta x, so the first rectangle, delta x is 1 times your function value at 1, plus your second rectangle, delta x is 3 times your function value at 4. Oops, I should be using C prime, plus C prime, delta x is 2, C prime of 6, plus delta x is 2, C prime of 8. And then let's go plug those numbers in. 1 times F prime of 1 is 4.5 from the table, plus 3 times C prime of 4 is 2.5, plus 2 times C prime of 6 is 1, plus 2 times C prime of 8 is 0.2. Okay, and then use your calculator, add this up if you need to. The arithmetic isn't too bad. And you should get 14.4, which means, or 1,440 calls. Okay, points on that is 1 point for your interpretation, 1 point for your Riemann sum, whether you have this line or this line, and then 1 point for the approximation.
do part D now. The total number of calls that the pizza chain receives for delivery on Friday night is 100s of calls. In 100s of calls. Can be modeled by the new function x squared over 200 minus 2x, where x is the number of delivery drivers. When there are 60 drivers, the number of drivers is increasing at a rate of 7 over 24 drivers per hour. According to this model, what is the rate of change of total delivery calls with respect to time in 100 pieces per hour at the time when there are 60 drivers delivering pizza? A lot of words there, but this is a related rates problem as well as a quotient rule problem because we need to find the derivative of the function. So f prime of x is x squared over 200 minus 2x, and then we're given that the rate of change of the driver is dx dt when the driver is 60 is 7 over 24, but it's decreasing, so make sure you catch that. It's negative. Okay, so the first thing that we need to do is to find the derivative. Oops, that shouldn't be f prime. So df dx is equal to df dt times dx dt. The chain rule. Okay, and the function is a quotient, so we're going to use quotient rule. Denominator squared, the denominator, times the derivative of the numerator, minus the numerator, times the derivative of the denominator, times dx dt. Okay, now we want to plug in x is 60, so df dx when x is 60 is 200 minus 120 times 120 minus 60 squared times a negative 2, and that's all divided by 200 minus 120 squared, and then we're going to multiply that by the rate of change, which is negative 7 over 24. So, using your calculator, plugging all those numbers in, you should get negative 49 over 64. So verify that doing the arithmetic. Okay, so points for that one. You're going to get 1 point for using the quotient rule correctly. 1 point for knowing that it's a related rate. So either having dx dt here, or showing this, or even right here, if you had that, it shows that you know it's a related rate. And then 1 point for your final answer.